Hi there. So today we'll take a look at a pretty cool workflow that we will install in GCP, which is going to consist of a rendering farm. So we're going to render a project in GCP, and we'll use Elastifile, the Elastifile cloud file system, as the NFS layer for the rendering nodes to read and write data for the rendering workload. So the architecture we'll take a look at today is something similar to this. So you'll have a bunch of rendering nodes here at the top. They're going to all share an NFS access to Elastifile, the fast tier for those render nodes to render the projects. And we'll take a look at cloud storage as well, because we've been putting the rendering projects in project in GCS that we'll copy on the NFS layer later. You can see in the diagram as well that Elastifile has got a feature called Clear Tier that allows for intelligent tiering between the Tier 1 NFS, the fast tier, and GCS. We will not take a look at that in that tutorial. We want to, really simply install Elastifile, install, render nodes, and do the job. So we're gonna do, all the steps. It's gonna be pretty detailed. It's gonna be a mix and match of GUI and command lines. The first thing we're going to do is to install the Elastifile cluster itself from the GCP marketplace, and then we'll install the render nodes. And in order to do that, we'll create an image using Ubuntu, and then we'll use the gcloud command to be able to deploy as many render nodes as we want. Because you might want to scale that. In our example, we'll deploy 4 nodes, and those 4 nodes are going to render some of the frames of the project. So before we begin, let's take a look at the project itself. So I have Blender running on the Mac here. I'm going to open the project we're going to take a look at. It's called NeckMesh BGE. It's a fairly simple project. Nothing too crazy because we're doing a tutorial here. We don't want to spend hours and hours rendering frames, right? So it's basically some sort of a robot arm, which is going to be animated, right? You can take a look at the composing and all the structure and the files we're going to use to do the rendering, right? And at the end, what the nodes are going to do is to render frame by frame all the different frames of the animation. Using the example here in the tutorial, we're going to render 10 frames only. Again, it would be a long tutorial if we would render everything. So the assumption here for that project to begin and for the tutorial to begin is that there's nothing in GCP, right? We're going to install Elastifile ECFS, the file system in GCP, and we're going to install the nodes and then do the connection and run the job. So the first thing we're going to do is to install Elastifile. So Elastifile can be installed directly from the Google Marketplace. So let's take a look at that, and let's do a search on Elastifile. There's different modules in here. We're not going to go into details of all those different modules. The one we want to use here is the Elastifile cloud system itself. So let's take a look at that. Launch it. And then you have different things here that you want to put in place. The version of the Elastifile cluster we're going to deploy today is version 3.0. We're going to give it a name, so we're going to call it rendering farm demo or tutorial. Oops, I'm in caps lock here. So we'll call it rendering farm tutorial, right? We're going to be into a zone that is close to where I am right now. I'm in the San Francisco Bay Area, so we'll choose to go into the West one. We'll use persistent disk for the boot. Don't change any of anything in the rest of the options here, and just go and deploy the Elastifile cluster. So what this is going to do, it's going to be done in 2 steps. It's going to deploy what's called the EMS before anything else is done. So it's going to be the Elastifile management system, and from that VM we'll be able to deploy the nodes themselves with the disks and access to NFS. So that's going to take just a little bit, and when this EMS VM is deployed, we'll have access to the cluster in a minute here with admin and then the link to connect and the password. Here you go. So this is the link to the EMS. This is the password and the user you're going to be able to use to connect. So let's take a look at that. I'm going to copy the password here, go and connect to Elastifile. Here you go. We have the cluster. So let's connect user and password and log in to Elastifile. We accept the license agreement. And then here you have the possibility to change your the default password that was given to the EMS with the password of your choice. Let's keep that. We're going to call this, so you have few fields to register, to enter here to register. We'll call it, I'll use mine actually. So Elastifile, my name is Yannick, and my email address is going to be yannick.yerm@elastifile.com. All right, next. It's going to check a few things, that all the prerequisites are in place for you to be able to install the cluster, network and different things. This should take, just a few seconds. And at the end, it's going to tell you if something is wrong and if you have to modify something in your GCP settings in order to be able to install the cluster. You go all green, everything is good in terms of VPC and subnet and firewall rules. So we can go and click on next. And this is going to be the actual deployment of the cluster. So we'll call it the rendering tutorial. You have different options here in terms of deployments. You want to deploy it in a single zone or two zones or more than two zones? We're going to deploy it into 2 zones. So it means that it's going to do 2 copies of all the data that you put in a cluster, right? Same here for the load balancer option. We're going to use the cloud load balancer, and you can see that it's assigning you an IP. That IP is going to be used later for you to be able to mount the Elastifile NFS share onto the clients, onto the rendering clients. So let's go for it. And the next option is going to be to choose what disk option you want to use in there. Local SSDs, SSD persistent disks for super high performance, and standard persistent disk. For the purpose of the tutorial here, we're not going to do crazy things in the tutorial. We're going to use local SSDs, and I'm going to use a very small cluster. Up to you here to choose a different size and increase the size of the cluster if need be. We don't need to do that. The rendering project is not super big. We're going to use the smallest cluster possible. And we can now deploy the cluster. So it's going to take a little bit to create the nodes and do all the work and all the setup with the network and the load balancer. And at the end of that, the next and final step is just going to be to create a data container, which is going to be the name of your NFS export that's going to be visible on the client side. The Elastifile cluster is deployed and ready to go. Next and final step, we'll just create a name for the container. So the data container is a logical entity, which is going to be basically the name of the NFS share that is accessible on the clients. You can set up soft and hard quotas here onto that data container, and choose to use dedupe and compression. We're going to use the default here, create the container. And notice here the command that you will use and that we will use later on the rendering node to be able to mount the Elastifile cluster onto the node, right? So basically your mount command with the IP of the load balancer and then the name of the data container and then where you want to mount it on your client. So this is it. Right, the Elastifile cluster is ready to go, waiting for you to connect nodes and be able to use it. If we go back in GCP and take a look at what we have as instances now, we should see 4. One, which is the EMS, the management system, and then the 3 storage nodes. Okay, ready to go. So next step, we're going to take a look at creating the rendering nodes. So in order to do that, we're going to create one node and then one instance, and then create an image from that instance and use the gcloud command to be able to deploy multiple nodes from the image. So let's go and create one instance. So we'll call it rendering demo or tutorial server. Here you go. We're going to put into the same zone, so West 1A. What we want to do here is to change we've been doing all the work on Ubuntu, so we want to change the OS and use Ubuntu 16.04 LTS. Let's go for that. And all the rest should be just fine. It's going to use the same default network. So let's create that instance. Here you go, the instance is created, right? So we can SSH to it in order to do all the steps to deploy the rendering node itself. So we're going to use Blender. We're going to download Blender, install it, install the NFS package. We're going to mount the NFS, the Elastifile NFS export on the client, and then we'll put an entry in the FS tab as well, so that whenever we deploy from the image, all the servers are going to automatically mount the Elastifile cluster on the node. Here you go. So we're connected as in Node. We're going to go and log as root to be able to do all the steps. So what I've done here is that I prepared all the different commands we'll have to apply to prepare the node, right? So install NFS, take a look at what mounts are exported from Elastifile, mount it, verify that it's been mounted, download Blender. We'll update the package on Ubuntu as well. We're going to entr the Blender and install it. Install a few packages that we will need for Blender to be able to work. Edit the FS tab file and put an entry for Elastifile. And then the next step here, we're going to grab the rendering project that I showed you in the beginning of the demo, that we actually put into a bucket, a GCS bucket that we've made public. So you can just move to the mount point, use gsutil to be able to copy the project into the NFS mount, unzip, and then when that is done, we'll be able to create the image and deploy 4 rendering nodes in here using that image. Here you go. For them to render the project at the same time in parallel, right? And then we'll take a look at a script that we put in place to be able to launch actually the rendering project, and we'll connect to one of the render nodes to see the result of the rendering. So let's go for it. We have a few things to put on the node here. So let's first install the NFS package. And then what we want to do next is verify that the mount is actually showing from ECFS. So see, the IP that we're using here is the IP of the load balancer. So it's actually showing that you can access the rendering demo FS mount from ECFS and mount it. So it's exactly what we're going to do. Let's mount it into /mnt on the rendering node on the instance here. It's mounted. Let's type mount to verify it's there. And it is, right? It is mounted here as an NFS file system onto the node in here. So that's good. Next, we want to download Blender. And once that's done, we'll install it, entr and install a few packages in order to be able to use it. All right, the package is downloaded. Let's continue. So after that, what we want to do is do an update of Ubuntu just to make sure the packages are up to date. And then we want to enter the Blender file. Let's go. Done. So Blender is installed. We want to make sure that we install a few packages that we will need here for Blender to be able to work on the machine. Here you go. And then we want to make sure that whenever the machine reboots, it's going to mount the NFS, the ECFS NFS mount automatically. So let's add an entry for that. So basically, this one here, just to make sure to mount the rendering demo FS onto MNT. There you go. Done. And then we want to be able to install and zip before we do anything and grab the rendering projects in GCS. Done. We want to go and make sure we go to MNT. There should be nothing in there. It's empty. So we'll use JSUtil to copy the project from that GCS bucket into the local folder. Done. And then the last part is to make sure that we unzip that and verify that the project is in there. Here you go. So the project is here. So when when we will have all the rendering nodes, mounting NFS and mounting the ECFS NFS, they're all going to be able to see the same access, the same content, the same rendering project, and be able to access the NFS folder all at the same time. So done. So now that the server is installed, we're going to use it to install all the other nodes. So we're going to create an image from that and use the image to deploy the different rendering nodes. So we can exit the SSH. And then what we want to do here in order to be able to create the image is to edit the VM before we delete it, and make sure that we uncheck the delete boot disk when instance is deleted. So we're going to delete the instance, but it's going to leave a boot image that we can use to create the image. Okay. So here you go. Let's actually save that. Done. So what we want to do now is to delete that VM instance, and then next create the image from the boot disk image. Instance deleted, and then we'll go into images, and then create a new image, and we'll call it the same name -image. So rendering tutorial server image. I want to make sure I copy that as well for later. And we want to use the boot disk that we just created from deleting the instance, which is called rendering tutorial server, and then create the image. Image is created. This is it, rendering tutorial server image. We're good to go. So next, what we want to do is to deploy 4 rendering nodes. And in order to do that, we'll use the jcloud command. So it's going to compute instances, create those 4 instances, 1, 2, 3, and 4, using that image, the rendering. We're going to make sure that we change that name here to the new image we just created. It's going to be an N1 iCPU 2. And then we're going to use the default subnet and the zone, which is going to be zone US 1A. So we're going to copy that command here and run it. And in order to run it, we're going to use the GCP Cloud Shell. So let's launch the shell in here. Here you go. So this command here is going to create the 4 different nodes. And then when those nodes are going to be created, we'll be able to run the actual rendering project, right? So remember, it's going to be 4 Ubuntu nodes running Blender as the rendering software. So here we go. Let's create the nodes. the nodes are created. Let's refresh the view of the instances. So now we have the Elastifile cluster that is running, and then we have the 4 different rendering nodes. So the next and final step is going to be to run the rendering itself. So in order to do that, and in order to distribute the load on the different rendering servers, rendering nodes, we created just a small script here, which is going to loop on the servers and distribute the rendering on the different nodes. So the basic command here is to call Blender here, so the Blender command, and then give it as an entry the rendering project file, which is a .blend file. And then here to say, hey, the output is going to be, frame number 1, 2, 3, 4, 5, 6, etc. And then what we'll do here as well is that we'll create a log file associated to it, so that if you have any errors or anything, you can take a look at the files, right? So in order to be able to run that script here, there's something pretty cool here in Google Cloud as well, in GCP, which is a code editor. So whenever you launch the code editor and then create the codes, you can create a file, you can save it to a file. So here we called it the rendering.sh. It's a shell script, right? Make it executable, and then you can run it from the Cloud Shell window in here. So it's just going to take a few seconds here to run and to launch the code editor. It's ready to go. So as you can see, my code is actually in here because I've been preparing for that tutorial and demo. But basically, what you would do is to go and do file, new file, and then call it rendering. We can actually do that. Rendering demo.sh. You go, and then here you want to make sure that you copy all the code here, and I'll give you the link at the end of the tutorial. We created a full detailed document about doing that, and the code is accessible in there. It's accessible on the Elastifile webpage. There you go. So just copy the code, and what we want to do here is to save the file, right? So we have one called rendering underscore demo.sh. If we go in the shell here, we should see the file, right? We should see that specific rendering demo.sh file. I want to make sure that I delete that from the previous demo as well. So if you take a look and do a VI on that file, it's going to be exactly the same content as the one that you have in the Cloud Editor. You want to make sure that you make that file executable. Here you go. ls. So the file, ls-la, the file should be an executable file right now. So we're ready to go. I'm going to launch the script. So it's going to go do a rotation on launching Blender on all the different nodes. And at the end, we should have 10 rendered frames into the MNT, the /MNT, the ECFS, NFS mount points on all the different servers. Here you go. So it's going to start the rendering nodes on all the nodes, rendering frame number 1 on server number 1, frame number 2 on number 2, etc., until it's going to reach launching the rendering on the 10 different frames. The rendering of each single frame is not that very long here. Again, we're using a project which is fairly easy to render for the tutorial. Otherwise, it would take forever to do it. Here you go. So it should go fairly fast. What we'll do here now is just to connect SSH to one of the rendering nodes. So we'll connect to the rendering node number 1 and go to /MNT. Let's do that again, MNT, ls. So we have all the different log files from the different servers, and if we go into the folder for the project here, what we should see is the project itself, the .blend file. But what we have now is all the different frames here that have been rendered. Frame 1, frame 2, frame 3. As you can see, it's going fairly fast for the tutorial. So it's actually finished, right? All the different nodes have been rendering the frames. So we have frames 1 to 10. we could actually, go and grab those frames and put it on the Mac here and do some assembling and do it. What we can do as well here is to, just take a look at the result of the rendering by starting the rendering on the Mac. It might actually kill the resource on the Mac because we're using a single node here to be able to render the project. But it should be okay. We should be able to take a look at the result at least, right? So let's actually render the animation. So it's gonna do it, and we should be able to take a look at what's going on in terms of rendering. So as you can see here, it already started to render different frames. As I just told you, it might take a little bit here, and it might actually kill the resource on the Mac. But what it's doing right now is actually what you did in GCP with 4 nodes, except that I'm doing it here on the Mac with only a single node, right? So it's doing it. It will take just a little bit to do it. So let's wait a little bit and take a look at the result of the animation a little bit later on. So here we go. So it's rendering on the Mac. It has already rendered, quite a few frames. So we can take a look at the result. We're going to play the animation. There you go. That's the project we've been working on in GCP, using multiple nodes to render some frames. So it's rendered quite a few frames here. So as you can see, that it has applied all the texture and the composing and everything, and playing the video. All right, this is it. So hopefully you enjoyed the tutorial as much as we enjoyed doing it. If you go and take a look at the Elastifile website, we created a full document on how to do it. So I encourage you to take a look at it. All the different steps that I've been doing in that tutorial are going to be very detailed into that document. So it's called How to Burst the rendering jobs to Google Cloud with Elastifile. So you can download it, and it's going to be very, very detailed so that you can do it at home and do your own rendering. Thank you very much.